the left, you'll see some double doors take you right to the bathroom in the lobby. If you go that way, you're gonna bump into something, people are recording, they'll be really embarrassed and everyone will laugh at you, so don't do that, all right?
And we just did bathroom break, so nobody's leaving, so don't, just get it
So
out of your
everyone,
head.
please remain seated, no feet up on the chairs, and we should be good, all right? Now, let's go ahead and get the elephant out of the room now. Anyone here feel a little bit dizzy or disoriented in this room?
No, not currently.
Just a little, kinda? I'll go ahead and explain why that is. So,
Is it haunted?
have you all learned about your angles yet? Like right angles, obtuse angles, all that? If you look around, there's hardly any right angles in this room. Everything's curves. Even the rows, if you see right here, are curved. You spend your entire life primarily in rooms that are squares and rectangles, right? So when you get in here, your brain is trying to make sense of it. Like, why is it so weird? How many have been on a boat before? Remember the first time you were on a boat? Your brain was like, oh, I don't know about this, and felt a little weird. Same kind of thing. How many have watched a 3D movie before? Have you ever tried to focus on something in a 3D movie and it gave you a headache?
Yeah.
Same kind of thing can happen here. Look at everything. Don't try and focus on something because that'll cause a headache. Otherwise, just watch the entire thing. That's it. Now, we'll go ahead and get started. Did you have a question? No? Okay. Let's go ahead and get going. Y'all are going to see some really cool stuff today. We're going to start off, though, by showing y'all what it's like behind the controls of a real spaceship, okay? So, go ahead and lower the lights here. Gotta wait for that to pop back up. There it is.
Oh, está mejor. Ah.
All right, ladies and gentlemen, what we've got here is the symbol for the Museum of the Southwest representing the sun. Oh, someone was that guy and had a flash on.
Flash off or put your phones up.
Gotta turn the flash off, folks. Now, we've got the symbol representing the sun with planets orbiting around. Now, these aren't all 8 of the planets in the solar system, but they are some of the greatest hits. But what I really want y'all to focus on is this right here. Buttons and status screens, flight stick here on the left and right, big viewport. This is the cockpit of the Space Shuttle Endeavour. If any of you have ever wondered what it looks like behind the controls of a real spaceship and not just one you see in TV and movies, here you go. This was the last American space shuttle before that program ended. Its final flight was in May of 2011, and during its time in service, this ship went on 25 missions up into space. And 12 of those missions helped build the International Space Station. And check this out. With its rockets, the Endeavour reached speeds of takeoff of around 17,500 miles per hour. To give y'all an idea of how fast that is, how many have been to Dallas before? Or El Paso?
Yes.
That's a long drive, right? It's a pain of a drive. It takes about 4.5, 5 hours, depending on how leisurely you're driving to get from here to Dallas. That trip, if you were traveling that speed, that's 17,500 miles per hour, will only take you about 1 minute and 6 seconds. It's not that way to travel, right? To give you all another idea of how fast that is and more perspective on what an astronaut goes through when they're up in space, check this out. The International Space Station is orbiting around the Earth the exact same speed, 17,500 miles per hour. It's not slowing down. It's going so fast around the Earth, the astronauts on board see a full day and night every hour and a half. It goes around the planet every 90 minutes. So, easy question here. How many sunrises do we see in 24 hours? How many sunsets do we see in 24 hours? An astronaut on board the ISS sees 16 sunrises and 16 sunsets every 24 hours. So, it's kind of like time travel, that for every day here on Earth, an astronaut technically spends 16 days on the space station. Now think about that. Imagine you're an astronaut and you go up onto the space station for a few months and your body gets used to that, gets acclimated to seeing all those sunrises and sunsets, and then you get back down to Earth. How many here gets completely messed up just having to turn their clock backwards or forwards twice a year? Right? When you lose an hour, it's a pain, it's horrible. Well, for some astronauts, when they get back down to Earth, the day feels like it lasts forever and the night feels like it lasts forever. And it really messes with their heads. Getting their internal clock back in the right spot is actually harder for some astronauts than getting used to gravity. That's one of the things they don't really tell you about in the recruitment brochure. Now, as you can see, all the buttons and switches and everything, pretty complicated to pilot this ship, right? You figure? But technology has changed. Have you all noticed, and I know y'all are in 6th grade, but how much technology has changed in just like the last 5 years? It's getting kind of crazy, right? Especially with AI and everything. show you now is the cockpit of a new spaceship called the Orion. The Orion is the hallmark of the Artemis project that's going to get us back to the moon for the first time since the 1970s. So, look at all the buttons and switches and everything. Think about how complicated it would be. And now I'll show you the cockpit of the Orion. And this is a little bit simpler. So, we've got an astronaut seated right here, but as you can see, it's primarily touchscreen technology, guys, just like you use on your tablets and everything else. So, on this one screen, they can highlight any part of the ship, like the solar arrays. They can see its temperature, how much battery charge is in it, different readouts on whether everything's doing okay, distance from Earth, their velocity, the mission elapsed time. And check it out, guys, they even got Alexa up there.
Alexa?
So Amazon has now moved beyond the boundaries of Earth's atmosphere. God help us all. But this gives you an idea of just how, now does this look simpler? Does this look like something you could potentially pilot? Maybe. I mean, you definitely would be a lot less panicked, I think, in terms of like, what button do I push? But who knows? This is just 15 years, guys. Who knows what spaceship's going to be like in 10 years, 15 years from now. So, we'll fade this out. And I said I was going to show you all some solar system things. So let's go ahead and pop up the evening sky. So this is the sky that's going to be over Midland, Odessa tonight. And let's go ahead and brighten up the moon a little bit more. So we got the moon here, and it's almost full. And we've got the stars up here, and then we have stars, we have the constellations. So these are the shapes that people thousands of years ago made up of the stars, and they used them to tell stories around the campfire, used them for navigation, and the most important thing, it let them know what time of year it was. So it was the best time to plant food, to harvest food. Like constellations were very important to our overall development as human beings. And these little stick figures that they connect the dots actually are supposed to represent bees. So, we got mythological figures like the Hydra, a centaur, angels. We have real critters like dogs, lions, and bears, oh my. All kinds of interesting things. But, if we go ahead and fade these pictures out, they definitely had to use their imagination, right? Like, this doesn't necessarily look like a lion or anything. But let's do this. Let's show you just how many stars are actually around our planet. Some of them we can't see because of atmospheric conditions. Some we can't see because they're too dim. A lot of them we can't see now because of light pollution. Has anyone gone camping and saw that the night sky looked a lot cooler than it did in town? Right? Because there's less light pollution messing everything up. So I'm going to go ahead and raise the luminosity, and you'll see just how many stars are around our planet. There we go. So with this many stars, some of these connect the dot pictures could be a little bit more intricate, right? So let's go ahead and pop those figures up. Yeah, see, that'd be a lot easier to do, having that many dots to play around with. But yeah, here are the constellations, just a tiny little section of our galaxy. Now, I want y'all to think about the dome as your personal spaceship today. We're going to go ahead and lower the luminosity just a bit. And I want y'all to do me a favor. Actually, let's go to the sky as it is right now. All right. I want y'all to do me a favor. We're going to count down. 5, 4, 3, 2, 1, and lift off. I want y'all to join along with me, okay? Ready? 5, 4, 3, 2, 1, lift off.
No, esto no toque.
So we're taking off from Midland, Odessa. There's the shadow of the moon. And here we are, ladies and gentlemen, at the most important planet in the entire universe, because it's the one we're currently sitting on. This is Earth. Now we've got the night side of the planet, and we've got the lights here from cities in Europe and Egypt and all of that. You want to see? I'll tell you what, at the end, I'll actually show you an aerial view of Tokyo. How's that?
Now I see the
We've got
sun.
India, we've got all kinds of cool stuff there. I think Japan's right around there. But you guys learn about Earth in other classes, so let's go ahead and fly to our closest neighbor.
Mars. Mercury.
So, we have got, ladies and gentlemen,
The moon.
the moon. I'm going to go ahead and write this up. Now, the moon here is our closest neighbor, and it is the only place in the entire cosmos that we have actually visited in person. In 1969, Apollo 11 landed on the moon. 3 gentlemen got there. 2 of them actually walked along the surface. We did a bunch of Apollo missions during the 70s, but we haven't been back. Now, one of the reasons we haven't been back, a lot of people get asked this question, is because we didn't have anyone to compete with anymore. I'll guarantee you that if China suddenly said we're going to make it to the moon in a year, we would try to get there in 6 months. So, let's go ahead and actually show you all what the surface of the moon looks like. This is a panoramic shot of the moon. This was taken during Apollo 17. This is Station 5. We've got an astronaut hopping around there. We've got one of the little moon buggies there. How many would like to go off-roading on the moon? How awesome would that be, right? But now we have got the Artemis missions to go back to the moon. We had the Orion spacecraft actually take off from Earth, and it did a full circuit around the moon and headed back remote control. No one was actually in it. Artemis 2, they're going to be doing the exact same thing, only astronauts will be behind the wheel, and we're going to go out farther into space than we ever have before. And all of this will end with Artemis 3, where they'll actually land on the surface of the moon. The first woman will be walking on the moon during this mission, as well as the first person of color, the first person of Asian descent, the first person of Latino descent. There's going to be a lot of firsts for humanity during this mission, and the cool thing is, ladies and gentlemen, they're going to be live streamed. So y'all will be able to watch it when it happens. And much like parents were able to tell their kids or grandkids where they were when Apollo 11 landed on the moon, maybe you'll be able to tell your kids and grandkids where you were when Artemis 3 landed back on the moon, which would be pretty awesome. Now, let's go ahead and fly to the center of the solar system. Now, the cool thing about this, guys, is we're actually traveling faster than the speed of light right now. It actually takes light 8 minutes from the sun to actually reach Earth. Light speed is not as fast as science fiction would lead you to believe. So, as we head here to the sun, also known as Sol, S-O-L, its proper name, a giant ball of hydrogen and helium that are reacting. It's basically like it's a campfire that's always having wood thrown on it. It's about 1 million Earths could fit inside the sun, so this little laser pointer, imagine that being the size of Earth. If that's the size of Earth, then that is probably about the size of the sun. Now you notice these dark spots that are all across the surface here. These are called sunspots, and what these are, it's part of the sun's magnetic field actually breaching and reacting with the surface. These are the coldest areas of the sun, believe it or not. They're a nice, chill 5,000 degrees. So, not something we can get close to, but here's the crazy thing about this. If we turned off the rest of the sun and just left the sunspots would be bright. It's just they're surrounded by so much brightness from the rest of the sun, they appear dark to us. But those are the darkest areas of the sun, and they're just part of the sun's massive magnetic field reaching the surface. So if you ever see those weird spots and wonder what those are, there you go. Now, I'm going to go ahead and show you all something known as an orrery. And what an orrery is, it's a map of the solar system. So this is going to go ahead and zoom out. Get into a proper position. So it'll move up here and then down, and then you'll see something really cool. You'll be able to see the orbits of all the planets in the solar system. So we have got Mercury, Venus, Earth, Mars, Saturn, Jupiter, Saturn, Uranus, and Neptune. Now, this right here, guys, is a great example of how difficult space travel actually is and how much math is important. Check this out. We want to launch a ship to Mars, so we do. Kind of a short trip, right? Now, let's wait a few months. Let's go, there we go. Now, if we launch the mission to Mars, look how long the distance is. That's because Earth's orbit around the sun is a lot faster than Mars's is. So we have to wait for these windows to open up for an actual fast travel to Mars. Otherwise, it would take ages for us to actually reach the red planet. So check it like this. Right now, just later in the year, we'd have to go across the entire inner solar system almost to reach Mars. Now imagine if we had to drop someone off to explore the surface of Mars, or a colony, or anything like that. Well, it's not necessarily that, it's just we have to leave them on Mars for like a year before we can come pick them up or supply them. So we have to make sure that we have a lot of stuff, a lot of factors figured out, and math is so important for that in order to make sure people are safe. So now, check it out. It's been an entire year later. Mars has done a full circuit, but we got to wait for Earth to catch up, and now we can do that trip again. But we don't have that much of a window until once again, just a few weeks later, that distance gets farther and farther and farther and farther away. So space travel is a lot more complicated than what you would see in like a science fiction.